Just to kind of start off, I want to do stuff a bit differently. I want everyone to kind of just look around and think how well you actually know the people around you. I'm going to wait, you're going to have to look around. Okay, great. Now let's imagine that we're not in Vegas, and that's not a dumb question. Think about the people that you work with. How well do you actually know them? And by extension, how well do you know the stuff that they deploy into production, into your clusters, whether it's identities, workloads, anything along those lines. Welcome, don't trust Rufus, he's a mole. So just a bit about me. As we've established, I'm not very good with trust, so you can choose whether to take it with a pinch of salt. I'm a security researcher at Palo Alto Networks, focused mostly around cloud, Kubernetes, and a lot to do with identity. So quick agenda for the day. I'm going to start off with the problem statement, kind of why I got into this research in the first place and why we ended up with this tool. Talk about the approach that I took for kind of solving these issues. Introduce KIEMPossible. Talk about kind of the flow, what happens behind the scenes when you actually run the tool. Do a quick pre-recorded demo. I don't really want to bore you with 40 minutes of going through logs, so it's about 14,000 times sped up. A bit quick conclusion, and then questions we'll do later in the hall if you want. So we're going to follow Kim, who's a DevOps engineer at Possible Solutions, and she's pretty much fed up with basically loads of alerts in production, which all stem from the kind of same root cause. She has no idea who has which permissions and what permissions they need. Why are they there? So basically, that's sort of the main problem that we're going to deal with today. And to kind of start doing that, we're first going to give a bit of background. So within Kubernetes, we have sort of the default, let's call it IAM kind of object. So for identities, we've got service accounts, we've got users, and we've got groups. One thing to keep in mind here, service accounts are the only ones that actually exist as an object within Kubernetes clusters. We'll get back to that later. But those are just the default ones. And then sort of the other IAM objects that aren't really identities, we've got roles, role bindings, cluster role bindings. I'll be using those interchangeably. And then we've also got integrations. So just to name a few, we've got historically AWS IAM, the famous AWS auth config map. A bit more recently, we've got EKS access entries, access policies. And for GKE, we've got GCP IAM. For AKS, we've got Entra ID. Now, just to give you a bit of a kind of idea of what it looks like, permissions in Kubernetes. So I'm assuming everyone here is familiar with AWS. So roles and cluster roles are sort of like policies in AWS. They're something that holds the permissions. Bindings are basically a way to scope out permissions and give them to a specific entity, to an identity that can actually perform actions. So cluster roles can be combined with role bindings and cluster role bindings to scope them to either the cluster level or a namespace level. And roles can only be used with role bindings to scope to a specific level. Now, sort of the first problem here, if you remember earlier, I said service accounts are the only things that exist, only identities that exist as an object in Kubernetes. How can we figure out which users we have, which groups we have? Now, sort of a sub-problem there is if we've got groups in our bindings that have users within them, but those users don't get permissions directly from bindings, how can we even know who the users are? We don't necessarily know who's got access at all, let alone which permissions they have. Now the next kind of stage of that is necessary permissions. How do we know what permissions are needed? They can change. How do we kind of separate that? So in my mind, I like to separate it to ephemeral resource permissions and non-ephemeral resource permissions. It basically means, non-ephemeral means it's sort of like a static object, static resource. It will only change if you actively do something to change it. For example, a secret. As opposed to ephemeral resources, for example, a pod in part of a deployment. That pod can be terminated and then sort of brought back to life, depending on the different cases, with a slightly different name. So that we'll kind of touch on that later when we get to resource names, but that's just something to keep in mind. Now, there's a really kind of cool research I like to talk about by, I hope I'm not butchering his name, Daniel Gajalik, Root and Prod. And he kind of talks about it more on the AWS context, but basically it's valid for any permission system. What about permissions that grant more permissions? So for example, if I can execute commands within a pod, and that pod has a service account token mounted, I can basically do anything that service account can do. So just to kind of get an idea of what the approach that I looked at here. So initially we're talking about three issues, right? How do we identify the entities in the cluster? How do we identify their permissions? And how do we identify the permissions that they actually need? So when we talk about the identities, how can we figure out who they are? The first one, which is quite easy, is service accounts. Like we said, they're objects, we can just list them. Looks like that. We've got the kind service account and then name and namespace that they're in. For users and groups, it's a slightly different approach. What we can do is we can go through the bindings and cluster role bindings in the cluster. So this is an example of a role binding, and as we can see, there's a subject there called Rufus, who is a user. Now, another issue here is, what if Rufus is part of a group? Or in this case, don't know. What if there's a group who has specific users within them? I can't list the users within a group. There's no list groups and there's no list users in Kubernetes. So if I get my permissions solely from a group, I don't exist in the bindings. As far as the cluster goes, I don't exist. I may have some authentication material, but that's it. Now, how do I figure out who those users are? We'll get to that a bit later, just kind of something to keep in mind. Second problem, how to identify the permissions. So basically, we go through the cluster roles, we go through the roles, and we flatten down the permissions to the lowest level. What does that mean? I want something that I can work with. Wildcard on pods at a cluster-wide level doesn't really mean too much to me. I want to know the specific permissions that a user has. So what we do is we break that down to every single verb that's relevant to that resource type at the lowest possible level. What does the lowest possible level mean? So as we said before, non-ephemeral versus ephemeral resource permissions. So for ephemeral resources, the lowest possible level is going to be the namespace. For non-ephemeral resources, we can also use resource names, which means we can use a specific, we can scope down permissions to a specific secret, for example. One kind of thing to keep in mind about resource names, they have to be an exact match. There's no wildcard, no regular expressions, nothing along those lines. Another thing to keep in mind for permission sort of discovery, special verbs. We need to figure out which verbs fit with which resources. For example, bind, impersonate, escalate. There's all kind of special verbs that aren't necessarily relevant for every resource type. A second thing to keep in mind is sub-resources. So for example, nodes proxy is a sub-resource of nodes. If I get the get permission on nodes, I also inherently get it on nodes proxy. But it doesn't work the other way around. If I get a permission on a sub-resource, that doesn't give me a permission on sort of the parent resource. So basically, for entities that aren't in the bindings, like we said before, how can we figure out what permissions they have? So this is what an event looks like in most of the distributions, and this is just sort of a default Kubernetes structure. And as we can see here, it's some event, the user system API server, created. And as we can see, part of the authentication material includes the groups claim. So I can see that this user is part of the system masters group. Now the system masters group has to get its permissions from somewhere, so that's going to be in the bindings. So basically, I can take that groups claim and mix and match. It's sort of like group inheritance kind of idea. Now the last thing is, how do I know what permissions they actually need? And for this, I kind of got help from another cartoon. Logs, right? It's pretty straightforward. If I need a permission, I'm probably going to use it. If I don't need it, I'm not going to use it. So the approach that I took here is basically look at the last X days of logs, look at the actions that each entity tries to make, and kind of take it from there. Now this requires a few things. The first is integration with the different log services, or an audit log file in the case of self-managed clusters. Another thing to keep in mind is we need to normalize the logs. There's key differences between the different providers. Not going to bash anyone in specific GKE, but basically they went and just changed the whole log, and one of the things that they actually did was take out the groups claim. So for GCP, we don't have the ability to do group inheritance, which is pretty annoying. Now another thing to keep in mind, this is all policy based. Logs in Kubernetes are configured at the API server level. We can configure exactly which logs we want and which logs we don't. It's quite granular. That's in regards to self-managed clusters. Managed clusters, that's part of the trade-off. We lose that. We don't have the ability to specify the specific logs that we want. We can just kind of say, I want all logs, I don't want any logs. Another thing that we don't have is visibility. For GKE, there's a specific repo where we can find sort of an idea of what the policy that they have is. But for AKS and EKS, they don't even give us an idea of what's logged. So I think about a year ago, Shay from Wiz did a really cool talk at Forward CloudSec about Kubernetes logging. And that kind of got me thinking of like, oh, I want to check that out. So I wrote a script that basically goes through every resource type in the cluster, tries to deploy it, does every single verb that it can do on that, and then deletes the logs, the resource. And then go and check the logs. At the time, again, it's about a year ago, everything was logged at some level. Again, this is kind of, for my use case, I don't really need all the information, I just need a log, I just need an event. But kind of it's important to stay vigilant because we don't have visibility as to when they change things, what they change, so we're not in control basically. Another note to make here, looking at logs for sort of last access is really, really cool for machine identities because they're pretty much anticipatable, right? They either run on a schedule based on different hooks, events, something along those lines. Human identities are a bit more sporadic. So I could, for example, not deploy a pod for 3 months and then suddenly decide, oh, I want to deploy something. It's debatable whether or not humans should actually have access to the cluster in the first place, but it's a different discussion. One kind of thing I want to highlight here, which I haven't really seen any research about, if you have, come tell me afterwards, it'd be really cool, is AI. AI can completely break this pattern of sort of anticipatable machine identity stuff. I'm really kind of excited to see cool research come out on that topic. So basically, with that out of the way, let's introduce KIEMPossible. So it's basically Golan's Golang-based tool. It may or may not have started off as Rusty cluster until I actually did some due diligence and realized that GCP and Azure basically don't really have an SDK for Rust at this point. It's an open source tool which basically implements the approach that we talked about. It does, I guess it's self-acclaimed Kubernetes infrastructure entitlement management. It basically gives you visibility on who has access to your cluster, what access they have, and what are they actually doing, what are they using within. Its kind of goal is to minimize identity-related attack surface in cubes, and it currently supports AKS, EKS, GKE, and self-managed clusters. Fairly extensive. I tried to make it as configurable as possible. There's a lot of environment variables that you can use. And again, basically, just implements the approach that we talked about above. Sort of the result of a run of the tool is 2 tables, one of which is the cluster permissions, sort of the last used, time, resource, those kind of things. And then another one which is sort of workload identity mapping, so mapping the workloads to their respective service accounts and also to cloud service accounts. We don't do cloud service account permissions yet, but that may be an extension. So hopefully you can't see anything because it's utter bullshit, but basically orange is AWS, blue is Azure, green is GCP, pink is self-managed, and purple is sort of a common process. So starting at the top, you run the tool, give it all the flags you want. First thing it looks at, what is the cluster type? If it's self-managed, we go ahead and get the cluster credentials from the kubeconfig. If it's one of the cloud providers, we authenticate to the cloud provider and then get the cluster credentials. We then enumerate, get all of the roles, all of the bindings, all of the cluster roles, cluster role bindings, and the service accounts, and we start calculating permissions, as we said before, narrowing it down to sort of the lowest possible version of that permission. Then if you specify workload collection, you don't have to. That obviously entails more permissions for the tool to run. It will collect all the different workloads, iterate over them, and then to make it easier to triage afterwards, it will also map the original owner. So original owner is sort of the parent workload of that workload. So for a standalone pod, it will be the pod itself. For a pod that's part of a deployment, the original owner would be the deployment. We then start going through log ingestion. For self-managed clusters, that would be just an audit log file. And for cloud providers, that would be the different logging services. For AWS, we'll handle access entries. We currently only do the top 5 kind of main ones because they're a bit tricky. They're static permissions and they don't really define them within Kubernetes. We then handle group inheritance using the groups claim in the logs, as discussed, except for GCP, which, I don't know, maybe they'll change, hopefully. and then we compare the database permissions to the log actions. Now, that's a tricky one, because if you remember, I said before, for ephemeral resources, the lowest sort of permission level that we have is a namespace. That doesn't mean I can't do an action at a lower level. So if I've got get on pods in the default namespace, that doesn't mean I couldn't get a specific pod within that namespace. So sort of the mixing and matching there is also a bit tricky. We then populate the last used time and the last used resource just to kind of give you more visibility. And if you pass the advise flag when running the tool, you'll also get an analysis of sort of the riskiest identities and permissions in your cluster. And at that point, it's up to you to go and take that information and minimize your attack surface. So hopefully, running on the hotspot, so I may not be able to do the demo. Should be a video. Yeah, no. Sorry about that, happy to show it later on if you want. So just a couple of gotchas. As we said, policy-based logging. We're kind of basing this all off the logs, right? So for self-managed clusters, you've got full control, but that does mean that what you specifically don't include or exclude from the logs won't be visible. We won't have it in the tool, you won't have it in the results. For managed clusters, the configurations aren't controlled by you and you don't have visibility into them, so you need to stay vigilant in regards to that. Second thing is shadow users. We talked about users that don't get their permissions directly from a binding, but rather from group inheritance, a group that's part of a binding and then the user's part of that group. Now, in that case, the only way we're going to be able to even know that that user exists is through the logs. And there's a full-on possibility that if you've run the tool on the last 7 days, there have been users that haven't done anything in those 7 days, so you might not get full visibility. Another thing is direct kubelet interaction. So the nodes proxy permissions, get and create on nodes proxy, basically allow us to interact directly with a kubelet on a given node. Now, the way that Kubernetes architecture works, a lot of the security checks are done at the API server level, which means that authorization is done there and logging is done there. So basically, if I've got get and create on nodes proxy on a given node, I can talk directly to the kubelet on that node and basically do anything within the realm of that node, regardless of what permissions I have, and it won't get logged. So there's a lot of sort of third-party vendors that use direct kubelet interaction for example, for metrics and stuff like that. So again, just to kind of be vigilant there. The tool may have some discrepancies if you've changed the permissions during the scan time frame and maybe an action was done and rejected and then it did work, kind of changes. At the moment, we don't support access entries for service-linked roles. Just a lot of work may happen down the line. And lastly, I may be a bit sour about this, which is why I say it quite a lot. We don't do GKE group inheritance. They kind of don't allow us to do that by removing the group's claim from the logs. Lastly, I've kind of established, I think, that you shouldn't trust me, so you can go ahead and scan that, but up to you. It's on the Palo GitHub, fully open source. Go ahead, try it out. The point here to be made is this isn't a product, it's a proof of concept. That is basically my kind of shout out to the community to say we don't have enough emphasis on this. Attack surface in Kubernetes, or identity related attack surface in Kubernetes, is huge. I don't think I've ever seen a cluster where I couldn't privilege escalate in some way, and definitely needs more attention from the community. Now, I know we don't really have time for questions, so feel free to grab me outside if you've got any. So I just kind of prepared a few questions ahead of time. That's it. Thank you very much for listening.